This is question number 2. So we have parkland. There's a river running through it. The river is shown shaded in the north bank. So this is the north bank. This is the south bank. That's 20, that's 20, that's cos, same domain, plus 40, plus 30. So the gap between here and here must be 10 meters, and that must be 50 there. Okay. South bank, the horizontal axis, or distance in meters. Swimmer starts to swim at point P, which is at 50 and 30. The swimmer swims north. Find the distance in meters the swimmer needs to get to the north bank. Got to swim across there, 10 meters. Okay, question number B. The swimmer swims east from point P. Find the distance to get to the north bank of the river. Okay, so now she's swimming east, so we're finding that distance across there. So I know that distance there will be some x value, and it will be 30. So if I make the top one equal to 30 and solve, so I'll do that over here. Okay, so I've entered my expression, which is the top expression, so the plus 40. I've made it equal 30. And since I'm going to get 4 answers, I thought I would put in my domain, which puts it between 50 and 100, so it's going to give me that answer only. If I select that, what are we doing? We're going interactive advanced solve for x, okay, and I get 200 on 3, so that's 200 on 3. Therefore, the distance should be 203 minus 50, which gives me 50 on 3. So 200 on 3 minus 50 equals 50 on 3. I'm looking for solve, just so that I get my method mark, F1 of x equals 30. They should be able to work out what we're doing there. On another occasion, the swimmer swims the minimum distance from P to the north bank of the river. So what are we doing? We're now swimming this distance here, which is the minimum distance. And this point here on the bank will be x and 20 cos of pi x on 100 plus 40. And I'm doing the minimum distance. So I should have the square root of x minus 50 squared plus the y values. So 20 cos of pi x on 100 plus 40 minus 30 all squared, because that point there is 50 and 30. And that will give me the distance, and I'm trying to minimize that distance. Okay. So if I bring up my calculator, open up a fraction bracket, and that's I'm going to have x minus 50 squared plus bracket all of that minus 30 squared, which gives me an expression for D, and with that expression for D, I'm going to minimize it. So calculation F min going from, for the x's, between 50 and 100. So I get a minimum distance of 8.47. So D minimum equals 8.475. Find this minimum distance to the nearest decimal place, therefore 8.5 meters. Did I need to find the coordinates? On another occasion, point P. Okay, so calculate the surface area of the section of the river shown on the graph on page 16 in square metres. Okay, so this is the same as a rectangle that is 200 across and 10 deep. So it's going to be 2,000 metres. It's going to be 2,000 metres squared. I could integrate from 0 to 2,000, 200 of top curve, which is this. Copy, paste, minus bottom curve, which is all of that, but instead of having 40, I've got 30 dx, and I'm going to get 2,000. Okay. Horizontal line is drawn through P. The section of river that is south is declared a no swim zone. Find the area of the no swim zone. So what am I looking at? So I'm going to draw a line across here at P. I know that that is at 50 and that is at 200 on 30. So I'm going to declare that this is symmetrical. So I've got to have this area here, and that will be the integral from 50 to 200 on 3. Top curve is 30 minus f2 dx, and that will give you that area. Plus, this will be a rectangle 10 times 100 minus 200 on 3, and then double it. So I'm going to have 2, and I'm going to have, and in here I'm going to have an integral, and the integral will go from 50 to 200 on 3. And the rule will be this rule here plus, so it's going to be 30 minus, so I'll open up a bracket, and I'm going to put in the bottom curve, which will be not plus 40 but plus 30 dx. And then I'm going to get out of that and go plus 10 open bracket 100 minus 200 on 3. And execute. I get that answer. And what form do I want the answer in? Nearest meter. Looking at 837.24. I'm looking at 837 meters squared. And what I've got up here will give me my method marks if I wrote this on the next page. And then we get up to F, where I'm seeing that scientists observe that the North Bank River is changing over time. It is moving further north from its current position. They model the prediction. So my new rule of my north one is K times F of 1, and my bottom rule stays exactly the same, K F of 2. Find the values of K for which the North River across the river, all parts of the river, is exactly less than 20 meters. So I want Kf of 1 minus f of 2 to be less than 20. So if I put a bracket, I'll copy that and I'll put a bracket around it. And I'm going to have another bracket, and in there I'm going to put this, but I want that to be 40 because my top curve is being multiplied by k. Variables k, and that minus that, I'll find out when it's equal to 10, and I'm going to, what are we going to do? Solve for k, can I do that? Of course, they're going to be, and of course it's going to be 1 because they are 10, but I want them to be less than 20, so if I put a 2 there. Now, the gap here will be smaller than the gap here because the gap here will be this value multiplied by k would get further apart than this value multiplied by k because it's a lower value. So I'm going to put in given k equal, given x equals 0, and I get k is 7.6. So that's the highest that k can be. So k is going to be less than 7/6, but it's going to be equal to 1. It can't be lower than 1 because if k is less than 1, then this would get smaller and it's moving north. So observe that it's changing, it is moving further north. So therefore k can't be bigger than 1, less than 1. So 1 k less than 7/6, and I won't include it because it is strictly less than 20, so it can't equal 20.